Now let's move toward our next topic, which is exponential form and Euler formula. Let's find out what's Euler formula first. E power iota theta equals cos theta plus iota sin theta. This is the Euler formula. Let's find the proof of this formula. So, e power z, as we know, is equals 1 plus z square over 2 factorial plus so on. We will take the left hand side equals e power iota theta and we will expand it like this. So we will have 1 plus iota theta minus theta square over 2 factorial plus iota theta cube over 3 factorial plus so on. Let's take this equation as 1. Now we have cos z, we know it, equals 1 minus z square over 2 factorial plus z4 over 4 factorial and so on. And similarly we have sin z equals 1 minus z cube over 3 factorial plus z4 over 5 factorial plus so on, and these results we calculated are from Taylor's series. So let's consider a right hand side equals cos theta plus iota sin theta. When we put the values of cos z and sin z in this formula, we will find out that 1 plus iota theta minus theta square over 2 factorial, and we are not going to find it the values of cos z and sin z in terms of z but in terms of theta. So we will have this result and so on. This equation is 2. Now by comparing 1 and 2, we have e iota theta equals e power iota theta equals cos theta plus iota sin theta. Now we'll know from the polar coordinates of a complex number is equals z equals r cos theta plus iota sin theta. Now we are going to add the value of e power iota theta as z equals r cos theta plus iota sin theta is equals to e power iota theta. So e power iota theta. So z equals r e power iota theta, and this is the required result called as Euler formula, and this is the required result. Now let's move toward our next topic, which is multiplication of complex numbers in polar form. So let's say we have two numbers as z1 equals r1 cos theta 1 plus iota sin theta 1. From Euler formula we can write this polar form as r1 e iota theta 1, and similarly we have second complex number in polar form as z2 r2 cos theta 2 plus iota sin theta 2 equals, and we are again converting this number into Euler formula. So r2 e iota theta 2. Now we are going to multiply these two numbers z1 cross z2. So these two numbers r1 r2 e iota theta 1 dot e iota theta 2. So r1 r2 e these two numbers iota theta 1 plus theta 2. So z1 cross z2. Now convert this number again into polar form, and we will have the result as z1 cross z2 equals r1 r2 cos theta 1 plus theta 2 plus iota sin theta 1 plus theta 2. This is the required result. Now let's move toward the division of complex numbers in polar form. As we said, we have two complex numbers, z1 equals r1 cos theta 1 plus iota sin theta 1. Similarly, we have z2 equals r2 cos theta 2 plus iota sin theta 2. We are going to convert these two formulas into Euler form. So we have r1 e iota theta 1, and similarly we have r2 e iota theta 2. Now we have two complex numbers, z1 and z2. Division of these two complex numbers in polar form is as r1 e iota theta 1 over r2 e iota theta 2. Now we will divide them, r1 over r2 and e iota theta 1 minus iota theta 2. Now we are going to take iota as common, so we will have z1 over z2 equals r1 over r2 e iota theta 1 minus theta 2. And similarly we are going to convert this into a polar form again, so we will have the results as r1 over r2 z1 over z2. r1 over r2 cos theta 1 minus theta 2 plus iota sin theta 1 minus theta 2, and this is the required solution, the division of these two complex numbers in polar form. Now let's solve an example related to the polar form of a complex number and get the better understanding of multiplication and division rule. So let's say we have a question, express z1 equals 1 plus iota and z2 equals under root 3 plus iota in polar form, and then find z1 cross z2 and z1 divided by z2. Now we are going to solve this question, as we have z1 equals 1 plus iota. We need to find r1 and theta 1 for this complex number. So for finding r1, we have real part of z square plus imaginary part of z square whole under the root. So we will have under root 2 r1. This is the value of r1. Let me write it here. So r1 equals under root 2. Similarly, we have z2 equals under root 3 plus iota. So we are going to find r2 and iota, r2 and theta 2 from this complex number. So for r2, we have real part of this complex number square under root 3 square plus imaginary part of this complex number square. So 1 square whole under root. So r2 equals a real part 3 plus 1 whole under root. So that's equals to 2. Let me write it here. r2 equals 2. Now let's find the argument of these two complex numbers. Under root 3 plus iota r2 theta 2. Now we have tan theta 1 equals y over x. Theta 1 equals tan inverse. What's the value of y here? It's 1. And what's the value of x? It's 1. So tan inverse, so theta 1 equals tan inverse 1. So tan inverse 1 equals pi by 4. So value of theta 1 equals pi by 4. Let me write it here. Theta 1 equals pi by 4. Now let's solve it for theta 2. We have tan theta 2 equals y by x. Theta 2 equals, what's the value of y? It's under root 3 over 1. So we have tan theta 2 equals 1 over under root 3. So we have theta 2 equals tan inverse 1 over under root 3. When we solve it, the value of tan inverse 1 over under root 3 is equals to pi by 6. So this value, let me write it here. Theta 2 equals pi by 6. Let's clean the board, and now we need to find z1 and z2. z1 equals r1 cos theta 1 plus iota sin theta 1. We need to put the values here. r1 under root 2 and cos theta 1 equals pi by 4. Similarly, plus iota sin theta 2 equals theta 1 equals pi by 4. This is the first polar form of a complex number, and now second we have z2 equals r2, which is 2, cos theta 2 which is pi by 6 plus iota sin theta 2 which is pi by 6. This is the polar form of this second complex number z2 here. Now we are going to solve them and find our answer. So we have these two complex number in polar forms. Z1 equals R1 which is under root 2 cos theta 1 which is pi by 4 plus iota sin theta 1 which is pi by 4. Similarly we have Z2 equals 2 cos pi by 6 plus iota sin pi by 6. Now we are going to express them both of the equation in Euler formula. So it's under root 2 e iota pi by 4, and similarly we have second equation as 2 e iota pi by 6. Now we are going to multiply and divide these two equations. When we multiply them, z1 cross z2 equals, this is z1 and this is z2. z1 under root 2 e iota pi by 4 and z2 2 e iota pi by 6. So we have 2 under root 2 e iota. Let's add these two values, pi by 4 plus pi by 6. So we have z1 cross z2 equals 2 under root 2 e iota. When we take the LCM of these two numbers, so we will have pi, so we will have 5 pi by 12. Now express this number again into a polar coordinate form. z1 cross z2 equals 2 under root 2 cos 5 pi by 12 plus iota sin 5 pi by 12. This is the required solution. Now again we are going to divide these two numbers. So according to the question we are going to divide these two numbers. So z1 over z2 equals, these are the value of z1 and z2. So under root 2 e power iota pi by 4. This is the value of z1, and similarly 2 e power iota pi by 6. This is the value of z2. So when we divide them, we will have 1 over under root 2 e iota pi by 4 minus pi by 6. So z1 over z2 equals 1 by under root 2 e iota. When we solve this, we will have pi over 12. Express this in polar form again. So we will have z1 over z2 equals 1 by under root 2 cos pi by 12 plus iota sin pi by 12. This is the required solution. The division of a complex number is here and the multiplication of these two complex number is here. Now let's move toward the last topic of this lecture, which is de Moivre's formula. Let's say we have a complex number as z equals cos theta plus iota sin theta. Then by de Moivre's formula we have cos theta plus iota sin theta m equals cos m theta plus iota sin m theta, where m is equals to 0, plus minus 1, plus minus 2 and so on. So let's solve an example based on de Moivre's formula to get a better understanding of this topic. So we have a question, let me write it here. Example, find 1 by 2 plus 1 by 2 iota power 8. We need to find the solution of this problem. So let's say we have z equals 1 by 2 plus 1 by 2 iota. Now we need to find the solution of r and theta of this problem first. So from here we have r equals 1 by 2 real part of z square plus imaginary part of z square whole under the root. So value of r comes out to be under root 2 over 2. This is the value of r. Now we need to find the value of theta. That's here. Theta equals tan inverse. What's the value of tan inverse y over x? So what's the value of y on x? Tan inverse, the value of y is 1 by 2 and value of x is also 1 by 2. So let me write it here. 1 by 2 over 1 by 2. So theta equals tan inverse 1. So theta equals tan inverse 1 becomes pi by 4. Now we have both values. We have theta and we have r value, the argument of a complex number, and we have theta and modulus of a complex number. Now we have z equals r cos theta plus iota sine theta. Let's put the values here. The value of r is 2 under root 2 over 2 cos theta, value of theta is pi by 4 plus iota sine theta, which is pi by 4. Let me write it here again. Now we have value of z equals 1 by 2 plus 1 by 2 iota. From the question we have this value of z, and now 1 by 2 plus 1 by 2 iota whole value 8 equals under root 2 over 2, 8 multiplied by cos pi by 4 plus iota sine pi by 4 whole value 8. We need to solve this further. Power 4 and 2 power 8 multiplied by, now we will use the de Moivre's formula. So 8 dot pi by 4 plus iota sine 8 dot pi by 4. So from here we have 414 4 2 times 8, 414 4 2 times 8, and this 1 times 2 power 4. So when we solve this further, we will have 1 over 2 power 4 cos 2 pi plus iota sine 2 pi. So now we have z power 8 equals 1 over 2 power 4 cos 2 pi plus iota sine 2 pi. When we solve this, we have 1 over 16. The value of cos 2 pi is equals to 1, and value of sine 2 pi equals 1, and this value is equals to 0. So 1 plus 0. So now we have a answer as 1 over 16. So 1 over 2 plus 1 over 2 iota power 8 have the solution as 1 over 16. This is the required solution.